All right, this video is for the part of Module 6 about equilibrium, and we're also kind of going into Module 7. So equilibrium is determined using the pricing system. So equilibrium is this idea that the price is stable and that the quantity supplied equals the quantity demand. So equilibrium is how we determine the price for anything. So it doesn't matter if we're talking about rulers, if we're talking about cars, or we're talking about apartments, or if we're talking about stocks. Supply and demand is essentially what determines the price of things. And equilibrium is important because this is where the market clears. We don't have anybody left willing to supply more. We don't have anybody left willing to buy more. This is where we have this nice kind of kumbaya moment between producers and consumers. They actually agree on something, which is a very rare case. So in this graph, I have an example of for ice cream cones. And so I have obviously equilibrium is at the price of $2, but equilibrium is also the quantity. How many ice cream cones will actually be sold at $2? So at $2, I have an agreement between supply and demand of 7. 7 ice cream cones will be bought and sold at $2. So we want to reach equilibrium because we have a clearinghouse. Everything is balanced. Now, in class, we did an activity where we were buying and selling rulers and colored pencils, and we basically looked at and determined what the supply curve, what the demand curve was for each particular, for rulers, but then we graphed it and we determined the equilibrium. So remember, equilibrium was wherever supply and demand are equal. Now, sometimes we don't have a balance, and sometimes we have what we call a surplus. So when we have a surplus, the quantity supplied is greater than the quantity demand. So we actually have more people out there that are willing to sell this product than there are people willing to buy it. So on our graph, here's our equilibrium, and if we have a surplus, what we have essentially happening is that anything above $2, we are going to have a surplus. So you can fill in that area above as part of a surplus. So anytime above equilibrium, you're going to have a surplus. But because there's a surplus, it automatically puts pressure on the price because we don't want to have a surplus. We always want to be at equilibrium. So what we're going to have to do is that we're going to have to drop the price to be able to reach equilibrium. So a good example of this is that after a holiday. So for example, Christmas. So during Christmas we have all these Christmas decorations out and trying to sell Christmas decorations. Well, any of the items, any of the decorations that are left over afterwards always go on sale, always go on clearance. What does that tell you? It tells you that originally they had the price too high. They had a surplus, so they had the price way up here somewhere. So they need to drop the price until they reach equilibrium, and then they will have a clearing. Now, you can also determine when you have a surplus, how much of a surplus there is on a graph, or even using a schedule. So what you can do is that at any point on our graph that's above equilibrium, so I'm going to pick out at $3. So at $3, I'm going to look at where the demand curve intersects that $3 line and where that $3 line intersects my supply line. Now, it's not quite off. I think my number is a little off here, but you get the idea. So at $3, approximately 3 people are willing to buy ice cream at $3, but we have 11 people that are willing to sell ice cream at $3. So in order to determine how many ice creams are going to go unsold and sit there melting, we have to take the 11 that are offered for sale minus the 3 that are going to actually be sold. So 11 minus 3 will give you 8. Okay, so you'll have 8 ice cream cones that are left that are not going to be sold. So obviously at the end of the day, when this particular ice cream truck is going around, if he has 8 ice creams left to sell, that tells you have a surplus, so then that puts pressure to drop the price down. And it's going to continue to drop the price down until you reach equilibrium and you get rid of the rest of the ice cream cones. Now, the opposite of a surplus is obviously a shortage. So the shortage is going to be when the quantity demand is greater than the quantity supplied. So in this case, what happens is that when we pull up our supply and demand graph, obviously we are going to shade in the region that's below equilibrium, and that's going to be our shortage. So anything below this price, we're going to have way too many people that want the product, but not enough people that are willing to sell it. So shortages are always going to be below equilibrium. Just like with a surplus, it does put pressure to be able to correct, because the market always wants to be at equilibrium. So if there's a shortage, what happens is that people are going to be kind of looking around trying to find it, and when you don't find something in a store, what happens? Good example of this would be hot ticket toy items every Christmas. A number of years ago, Tickle Me Elmo was the example. And parents were going all over looking for Tickle Me Elmo. They could not find it in any of the toy stores. So what do? They gotta have it for their child for Christmas. So they go out and they go looking online. So you go online, you go looking on eBay, Amazon, you find it. However, what happens to the price? You're going to probably pay a significantly large number more than what the price in the store was. The reason that is because the price was set too low in the store. So we have a shortage. Another example of this would be we could actually tell how much of a shortage there is by looking at any particular price. So for example, let's say that I'm going to pick out the lowest price on here. Let's say I'm going to pick out a price of 50 cents for my ice cream cones. Okay, and at 50 cents, I have one person willing to sell an ice cream cone at 50 cents. But I have 13 people that want ice cream cones. Well, according to 50 cents, how many people are going to go without ice cream? If you answered 12, you would be correct, because there's 13 people that want it, only one that's selling it, so 13 minus 1 will give us 12. So again, that will tell us how many we are actually going to be short. All right, now, last part about this is that you will notice that the supply and demand are what actually makes up equilibrium. And we already know that supply and demand does not stay the same. So as a result, we have to talk about how equilibrium can change, because it can change. So these are examples for the ruler graph. So if you remember in class, or if you were not in class, hopefully you watched the other video, looking at how we determined our supply and demand for our ruler graph. So what I want you to do is I want you to add this to your ruler graph. If you have room on the front of that pricing system or at work paper, you can do it there. If not, you can flip it over and do it on the back. I want you to add these 4 examples. All of them relate to your ruler graph. I want you to go through, see if you can figure out, number 1, is it supply or demand that I'm using the example for? Number 2, is this a right or left shift? I want you to draw the graph. So remember, now we're graphing supply and demand. So you have to draw what the X, the supply and demand X. Okay? So draw your shift. And then what happens to equilibrium? Remember, when I ask what happens to equilibrium, we're talking about equilibrium, price, and quantity. Equilibrium has 2 parts. It is not okay to say equilibrium goes up. That is not acceptable. All right. Pause the video right now. Go through it yourself, see what you can do, come back, play the answers. All right, hopefully you have a guess on all of these. The first one says you can use your iPad to graph your demand and supply curves. So if you remember, or in class, I had everybody buy 1 ruler and 5 colored pencils, and they actually use the ruler. So if all of a sudden you can use your iPad to graph instead of your ruler, all of a sudden that changes the demand. Okay, and what happens is that it's going to cause a left shift in demand, because this is going to be a substitute item. You don't have to use your ruler, you don't have to buy a ruler anymore, so you're not going to, the demand for rulers are going to decrease. So you're going to draw a left shift in demand. So here's our left shift. Now you have to look at what happens to equilibrium, price, and quantity. So notice that the equilibrium was originally here because that's where supply and demand meet. Now we have a new equilibrium where our new demand curve intersects our old supply curve. So now our price is going down because it's going from here to here. Okay, so our price is going down. And our quantity is also going down because its quantity is going from here to here. So our quantity is going down. Number 2, the cost of ink decreases. All right. Ink, I said, was a input used to make the ruler. The ink on the ruler, like the ink for like the lines and the numbers. So this is going to be a supply shift, okay? Because if the price of ink decreases, that means that the ruler people can go and make more rulers. So it's going to be a supply right shift. So we're going to shift the supply curve to the right. And again, we have to talk about what happens to equilibrium, price, and quantity. So now, here's our old equilibrium, here's our new equilibrium. So looking at our old price is here, our new price is here. So as a result, our equilibrium price dropped, and our old quantity is here, and our new quantity is here. So our quantity went up. Number 3 says the producers expect the price of rulers to rise next week. All right, this is going to be supply because I specifically said producers. Now, if you remember when we talked about the factors that cause a change in demand and the factors that cause a change in supply, there was an expectations for both of them. You can differentiate between the two based off from what we are saying as far as who's doing the expecting. So in this case, I said producers expect, so it tells you it's supply. If I said companies expect, suppliers expect, that tells you it's supply. If we said people expect, individuals expect, consumers expect, that will tell you it's demand. So this is supply, and if producers are expecting the price to go up next week, remember, producers like high prices. So if the price of rulers is going up next week, when do you want to be selling? Now when the price is low, or next week when the price is high? The answer, of course, is next week. So as a result, this is going to be a left shift now. So I'm not going to sell a whole lot now because I know I can get more money next week. So here's our left shift in supply. So now we can look at what happens to our equilibrium, price, and quantity. So here's our original equilibrium. Here's our new equilibrium. So look what happened to my price. So my price from here to here. So my price went up. Look at what happened to my quantity. My quantity went from here to here. My quantity went down. All right, last one. You get colored pencils free with the purchase of a ruler. All right, now this one particularly applies to what we did in class. So if you remember in class, I had you buy 5 colored pencils and 1 ruler. So in this instance, colored pencils are considered a complement to rulers. And this is a complement for the buyers, not the sellers. So this is going to be demand. And if you get free colored pencils with a ruler, well, heck yeah, I'll buy a ruler. So this is going to be a right shift in demand. So now we draw our graph. Here's our right shift. Now we have to talk about what happens to equilibrium, price, and quantity. So here's our old equilibrium. Here's our new equilibrium. Here's our old price. Here's our new price. So our equilibrium price went up. Here's our old quantity. Here's our new quantity. So our quantity also went up. Now, I had you to notice, if you noticed a pattern when you were doing these, yes, there is a left shift in demand and a right shift in demand, a left shift in supply, and a right shift in supply. Every time you do those, left shift in demand, it will always cause the price and quantity to decrease. If you do a right shift in demand, it will always cause the price and quantity to increase. If you do a right shift in supply, it will always cause the price to go down, the quantity go up. If you do a left shift in supply, it'll cause the price to go up, the quantity to go down. As a result, I want you to add your ruler graph to your graphing section of your notebook. Now, the last thing is that what happens if both changes at once? Now, if both changes at once, what will happen is that you will have some of equilibrium that you will know and some of equilibrium that you won't. So here's what I mean by that. So we're going to start with our regular supply and demand curve. Here's our original equilibrium. We'll label that as E1. Now, let's say that we have a case where both supply and demand are shifting to the right. So here's our right shift in supply, and here's our right shift in demand. So now we have a new equilibrium, which is here. Notice what happened to our quantity. So our quantity is going up for sure. But the question is, what happened to the price? The price is actually unknown because you don't, in this case, the way I drew it, the price looks like it dropped just a little, but actually it's depending upon how much the supply and demand curve changed. So when the price, demand and supply both shift to the right, it increases the quantity, but the change in price is unknown. You don't really know what happens. It depends upon how much the demand and the supply curve shifts. Let's try a different scenario. So I'll take those back. What if we had both of them shift to the left? So now we have both of them shift to the left, and now here's our new equilibrium. Okay, again, look at what happened to the quantity. For sure, you know the quantity is decreasing, but really it's indeterminate what happened to the price. So the way I drew it, it looks like the price went up just a little bit. But again, you don't know because it's dependent upon how much the supply curve shift or how much the demand curve shift. So anytime both supply and demand shifted to the left, the quantity decreases, but the price change is unknown. So what if we did one of each? So what if the supply curve shifted to the left and the demand curve shifted to the right? In this case, we know for sure, there's our new equilibrium, we know for sure that the price increased, okay, but we don't know what happened to the quantity. The way I drew it, it looks like the quantity might be slightly down. Slightly. But again, it depends upon how much the supply and demand curves actually shifted. So we don't know that. And if we obviously do the opposite and have the supply curve shift to the right and the demand curve shift to the left, what we have happening is a new equilibrium there, which again, we can tell for sure that the price is decreasing, but we don't know what happened to the quantity. The quantity is unknown. It looks kind of like it's slightly increased, but you don't really know that. Okay, so keep in mind that when you draw this out, you'll be able to determine this, but generally speaking, these are kind of the rules that apply. So if you have only one that's shifting at a time, it's a lot easier to predict. All right, that's it for now. Let me know if you have any questions.